Hi grade 10s, here is the second part of 4.4, which is about relating fractional exponents to radicals. Remember that the rule we were discussing is x to the power of m over n can change to n as an index and m as a power, and the power can be inside with the x or outside the root, either one. So let's look here. The question says evaluate, which means we're going to need to come up with an answer. So let's start by taking the 0.04 to the power of 3 over 2 and changing it into a radical. So the 2 is the index, which means it's a square root, and the 3 is the power. Now, I see a 4 here, and I know that 4 is a nice square root number. So when I square root that, I'd just get 0.2, but then I still need to apply the cube onto it. So 0.2 cubed ends up being 0.008. Let's try b then. b is 27 to the power of 4/3. So again, first we're going to change that into a root. So it's going to be the cube root of 27 to the power of 4. Now again, cube root 27, that works nicely. The cube root of 27 is 3. So that means it becomes 3 to the power of 4. Again, that 4 hasn't been used yet. So then when we do 3 to the power of 4, we end up with 81. Let's look at c. c is negative 32 to the power of 0.4. Now this is a little tricky because 0.4, we need to write that as a fraction. So 0.4 really means 4/10, and if you can reduce that, would be 2/5. So really we have negative 32 to the power of 2/5. Now if we change that into a radical form, the 5 is the index, the minus 32 is the base, and then we have 2 as a power. Now the 5th root of minus 32 is actually minus 2, because minus 2 multiplied by itself 5 times is minus 32. So really what we have here is minus 2 squared, which is going to equal 4. So the tricky part about that question is changing that decimal into a fraction. Again, 0.4 has one decimal place, which means it's talking about a tenth, because a tenth is 1 0, or 10 is 1 0. So it's 4/10, which can be reduced to 2/5. That's how we did that question. Now the next thing we're going to look at is a word problem. These word problems are they're going to be given to you the formula that you need to use. So here it says you have a formula. B is the brain mass in kilograms, and M is the mass of an animal's body in kilograms. So we're talking about how heavy the brain is compared to how heavy the body is. So here we're going to start with a husky that has a body mass of 27 kilograms. So that's going to go in the spot for M. So B equals 0.01 times 27 to the power of 2/3. Let's start by dealing, according to BEDMAS, with the exponent. So we're going to start with this part. So 27 to the power of 2/3 is actually the cube root of 27 squared. Again, the 3 is the index. Now I also know that the cube root of 27 is 3. So really what we have here is 3 squared, and 3 squared is 9. So we have 0.01 times 9, which is 0.09. So 0.09 kilograms is the weight of the husky's brain, since it weighs 27 kilograms. Now let's look at part B, because part B actually it doesn't work nicely with the numbers, but it does say estimate. So when we're estimating, we can use our calculators on this, and it doesn't need to be exact. So B equals 0.01, and then it's 200 to the power of 2/3. So your calculator actually does have a button that can do this for you. It'll be something like an exponent of x over y or something like that. It might be like m to the power of x over y or something like that, where you can type in that fractional exponent. If your calculator doesn't have that button, maybe you need to convert it into a cube root first. So the cube root of 200 and then squared, because your calculator will have a cube root button. So you just need to do a little bit of figuring there. Once you type it in properly, the number that you should get is 34.2 approximately. It was like 0.1999 or something. So about 34.2. Then we multiply that by the 0.01, and you should end up with 0.34 kilograms for the brain mass of a polar bear. So again, what's really important in this question is that you make sure you know how to do this part on your calculator, and you need 34.2 as an answer. We'll finish off this lesson then with some textbook questions, continuing with these fractional exponents. Have a great day.